family. These are the solutions for the check for understanding regarding power, which was lesson 76. These solutions are going to be a little bit more in depth because I think that they add a lot of information to what we talked about in class in terms of power. So I'll try to keep it short so I'm not taking up too much of your time, but a lot of number 58, rather than being like a practice what you know about power, I think that there is a lot to be gained through doing these problems. You're learning more about power rather than just practicing what you know about power. So that being said, let's dive right in. So the setup is that you manufacture and sell a liquid product whose electrical conductivity is supposed to be 5. You plan to make 6 measurements of the conductivity of each lot of product. If the product meets specifications, the mean of many measurements will be 5. You will therefore test that your mean measurement is 5. Your alternative is that it's not 5. If the true conductivity is 5.1, the liquid is not suitable for its intended use. You learn that the power of your test at a 5% significance level is 0.23. So when they say against the alternative mu, I know what they mean by that is our product that we manufacture, sorry, I was looking for the correct vocab word. If we're manufacturing correctly, our mu is 5. If it's 5.1, then we can't use the liquid. So they're saying that the power of your test, if the true mu is really 5.1, is 0.23. So they ask, explain in simple language then what the power of 0.23 means. If the true conductivity is 5.1, so that's why they're saying this. Against the alternative 5.1, what they're meaning is if the true value is 5.1, there is a 23% chance or a 23% probability that we will reject the null in favor of the alternative. So if the true mean is 5.1, the chances that we will correctly reject is only 23%. That is not a great power. Remember, we want at least 80% power. So this is not looking good for us because if 5.1 means that it's not suitable for the intended use, you're going to want a power much bigger than 23%. If the mu is truly 5.1, you want there to be like a 99% chance that you are going to reject the null. So, explain in simple language what it means. And I had to write up here, power means that you correctly reject. So, if mu is really 5.1, then we should reject HO. Well, what are the chances that that is going to happen? Only 23%. So I'm going to say that one more time. If mu is really 5.1, we should reject the null. Because obviously, if it's 5.1, then it's not 5. What are the chances that we will actually reject, that we will do what we're supposed to do? Only 23%. B, you could get higher power against the same alternative with the same alpha by changing the number of measurements you make. Should you make more measurements or fewer measurements to increase power? I think this one is very straightforward. To increase power, we need more information, so we should take more measurements. Now the next one is the one where we're actually going to add to our understanding of power. And I had to write a lot of things down in this section to wrap my mind around it. So, before we go into this, I just want to reiterate, I had to look through my notes. I had to write things down. I really had to think about the connection between power and type 1 and 2 errors before I could do these problems. I'm telling you that so that you know, if it is hard for you to do part C, let it go. Study other things. Focus on your strengths. Do not waste hours of your time trying to figure out the understanding behind part C. If you understand it, excellent. If you don't understand it, then focus your attention other places, because as long as you have some strengths, some things in your toolbox, you'll be fine. You don't need everything in your toolbox to be successful. Okay? Okay. So, part C says, if you decide to use an alpha of 10% instead of 5% with no other changes, will the power increase or decrease? Justify your answer. So we know that the power will increase because of this page. If you increase your alpha level, that means it's easier to reject, because remember, we only reject when the p-value is lower than alpha. So if we make our alpha bigger, the likelihood that we will reject is higher. So that's what we mean when we say if we increase our alpha, we make it easier to reject, because we only reject when the p-value is low. So if you make the number you compare it to even bigger, then that means there's more opportunity for your p-value to be lower than alpha. So if you increase significance level, it's easier to reject the null. Well, why does this increase your power? Because we know that it increases power, but why? Why will this increase your power? So I had to write this down. Sorry, my paper got all tangled. Okay, so right here I wrote that first point. Increasing alpha makes it easier to reject the null. How is that related to power? Because power is when you correctly reject. So power is related to the circumstance of rejecting. So power is when you correctly reject. So if you make it easier to reject, your power is higher, because your power happens when you reject. And say that one more time. You make it easier to reject the null, you make your power higher, because power is related to situations when you reject the null. Okay, now let's dive in a little bit deeper into that. So this is the picture that I had to draw in order to understand this. You should add as little or as much as you understand and think would be helpful. So when you increase alpha, it means you increase the probability of a type 1 error. Why is that? because increasing alpha means it's easier to reject. So you're more likely to reject. Well, a type 1 error only happens when we reject the null. Type 1 error only happens when we reject the null. So if you make it easier to reject, then you make the probability of a type 1 bigger. Well, remember, type 1 and type 2 are conversely related. So if you increase your type 1 error, that means you decrease your type 2 error. Why? Because type 1 only happens when we reject. Type 2 happens when you fail to reject. So if you make the chances that you're going to reject higher, that means that the chances that you fail to reject are lower. So if you increase the probability that you'll reject, you decrease the probability that you fail to reject. This ends up resulting in more power. The fact that you decrease your probability of failing to reject increases power. So why is that? Okay, so this guy right here, this first line, is this, just written out with more detail so that I had a better understanding of what happened. So what we need to connect now is these two things. Well, it turns out that power is equal to 1 minus the probability that you will make a type 2 error. Why? Why is this related that way? Well, look at each scenario. Power is when you should reject and do. That is opposite of a type 2, which is when you should reject but don't. Those are two parts of the same whole. So you have this bubble, which is all of the situations in which you reject. So you have the chances that you should reject and do. If you add that to should reject but don't, it equals 100% of the times you should reject. So, power is 1 minus the probability of a type 2 error. So the chances that we should reject but don't for this problem is 77%. The chances that we should reject but don't, the chance that we fail to reject when we should, is 77%. The other part of that is the 23% chance that we should reject and actually do. So these two things are related in this way. So maybe I should write this down. Remember, you only write down what is most applicable to your understanding. So power in this problem, I want a different color. Sorry, if I can find one and it doesn't take me 10 years, I'm going to use a different color. It is taking me 10 years. I apologize. Power in this problem is 23%. This is we should reject and do. Probability of a type 2 error then is 77%, and what this means is we should reject but don't. So now I know this relationship about power. that power is 1 minus my probability of a type 2 error. What is the takeaway then before we do the last part? So I feel great about part A. How do I interpret the power of a situation? It's the chances that all correctly reject the null. B, I feel good about the fact that if you increase sample size, you increase power, because the more information you have, the better, the easier it is to get the correct conclusion. And remember, power is when you correctly reject. C, the biggest takeaway from here is that when you increase alpha, your power increases. So that's the first thing. If you increase alpha, the power increases. The second thing is this relationship. Power is equal to 1 minus the probability of a type 2 error. So if you don't understand the background of it, at least memorize those two things, because you don't have to understand the why in order to be able to apply it. So for instance, if they said your power is 23%, what's the probability you're going to make a type 2 error? You don't have to understand how they're related to say, oh, well, I know it's 1 minus this, and get 0.77. So the takeaway for part C is power increases when you increase alpha, and this relationship. Now the last one is related to the 4 ways to increase power. And in class, I can't remember if I said this on the session that I actually recorded, but I could not understand what the world they were trying to say for 3. The phrasing, get an alternative value farther away from the null, did not make sense to me, because the word get implies that you are controlling the value that you can use, or the value that you get from your sample. This is the wrong word to use. They should not be using the word get. So cross that out and write use instead. Use an alternative value farther from the null. Because remember, the farther away your alternative value is, the more obvious it is that the null is wrong. So this goes back to our notes where it says observations that are very, very far from the parameter value. So it's this. Values of the statistic far from the null value give strong evidence against the null. So the farther away your alternative is, the more likely you are to reject the null. So this is the case where our basketball shooter says he makes 80% of his shots, but then only makes 20%. 20% is so far from 80%, it is very strong evidence against the null, which means you're more likely to reject the null. So how is that related here? Well, remember, power is this idea that you'll correctly reject. You are trying to determine your ability to reject the null when you should. So I'm going to say that one more time. Power is your ability to reject the null when you should. So here they're saying, well, if you look at an alternative of 5.2, will you increase power or decrease power? So what this means is, what are the chances that you'll correctly reject if the mu is really 5.2? Well, this is bigger than 5.1. This is farther away from the null of 5. So now we're saying, well, if we're farther from the claimed value, are the chances that we're going to reject going to increase or decrease? They're going to increase, because the farther away from the parameter you get, the stronger the evidence you have that the null is not true. So the power will increase because 5.2 is farther from the null of 5 than 5.1 is. So I now understand this bullet point in my 4 factors that increase power. All they're saying here is, if your alternative value is farther away from the claimed value, it is easier for you to reject. So, if it's easier to reject, that means your power increases. Okay, I think that is it for this check for understanding. I know 20 minutes is a little bit more involved, so remember, take from this what is most helpful to you. In the very least, the additional knowledge that we've added, you need to know this relationship. It's good if you have an understanding now of why this increases power, part D. And I think that's it. So if you watch this whole thing, excellent, A+. Thank you for doing that, and hopefully it benefited some of you guys. If you have questions, as usual, send them my way. That's it. Love you guys.